Hi, and welcome to CTS 120, Hardware Software Support 1. My name is John Armke, and I'll be your instructor this semester. This is Chapter 1 of 9 for this particular class, and we're going to be covering how to disassemble and reassemble a personal computer. So we're going to look at how to do the disassembly and reassembly safely, while being able to identify various external ports and major components. We're going to do the same thing with a laptop, being able to discuss some special considerations for how we service laptops also. Now, every technician should know how to put a PC back together after taking it apart. Taking it apart is just a matter of finding places where there are fasteners and removing them. But putting it back together correctly is what we do differently than most people. You know, a 5-year-old with a screwdriver could possibly take a computer apart, but to reassemble it and reassemble it to where it functions, that's the challenge. So we've got 7 steps to consider. Number 1, we must plan and organize our work. Step 2 is to organize the case and examine the system. Step 3 is to remove expansion cards. Step 4 is to remove the motherboard. 5 is to remove the power supply. 6 is to remove the drives. And 7, which is essentially the previous 4 steps in reverse, is reassembly. So let's look at our step 1. Document consistently. If there is anything that I will exhort you to do throughout the entirety of this semester, it is to document as you work. Document beforehand, document after. We need to plan, we need to take notes, and we need to be able to give a wrap-up when we're finished. Lab safety must also be observed, because while notes allow us to backtrack and review our process, we can't allow the note-taking process to impede our ability to make sure that we don't have heaps and drifts of paper on a desk, that we don't have pencils that are rolling off the desk and possibly forming trip hazards, that we don't have a diminished workspace due to note-taking. It also helps to have some organizers, things that can allow us to keep small parts all in one place. We want to avoid stacking components on top of each other. That's a big no-no if you want to avoid ESD. We also want to be careful about touching integrated circuits with our hands or with magnetized tools. Magnetized tools, of course, could possibly disrupt the ESD balance of a particular component or act as a vehicle to discharge your body's own electricity into the component in question. If you touch the edges of the integrated circuit's connectors, you may also cause corrosion. The oil and dirt on your fingertips is a material called sebum, which helps to waterproof our skin, but also could possibly damage connectors, especially those made on slightly cheaper products. Make sure that you're aware of your environment. As we talked about in Appendix A, things like long hair, jewelry, and loose clothing could accidentally contact an energized component and cause an electrostatic discharge. Whenever we're working with equipment such as a monitor or a power supply, something that is considered to be highly energized, we want to treat it as a black box. Black box is often a term we use in programming to describe abstraction or obfuscation. The idea is input goes in one side, output comes from the other, and we never consider what the function is inside. Now, obviously, there are other courses where we may actually go through the process of what goes on inside of a monitor or a power supply, but in this case in particular, we're going to consider that we should never remove the cover or probe about inside with tools or fingers. You also want to watch out for sharp edges on your case. The case, which may be considered an energized surface while the computer is powered, expansion cards, which can be easy to break. You know, there's a lot of potential force that you can put on those connectors, and exposed connectors that have pins or other types of sharp objects that could catch your fingers. Now, the things that we should have in our toolkit, if you will, would be the following. Now, obviously, this graphic here is pretty solid. This is one that I picked up, I believe, on Amazon. It is a 54-bit driver kit with spreaders and some extra tools for calipers and suction cups, things like that. That's more so for working on things like smartphones. The toolkit for working on a PC is a little bit less complex, but we would need to make sure that we have an anti-static strap. That's the blue band you see in the bottom left corner with the curly coiled little connector in the alligator clip. Both flathead and Phillips head screwdrivers, you can find these in a couple of different configurations. It just depends on what type of computers you're working on, whether you'll need some of the really small ones. Security screwdrivers, that's where that 54-bit set you see there is pretty handy. While size T15 is pretty common, if you work on video game controllers or things like that, that tends to use a lot of T9s. If you work on smartphones, then that tends to use very, very small PH style screwdrivers. I'd say you could probably get down as far as a PZ00 or even a Y style screwdriver. Apple uses their own proprietary pentalobular screws, meaning that they have these kind of blob-shaped 5 fins on the screws in order to take it apart. If you've ever seen somebody try and take a screw out with a screwdriver that didn't match, you'll notice that the metal tends to sustain a lot of damage. This is unadvisable in a professional capacity, so it would behoove you to make sure that you have a driver kit that supports the different screws that you will need to remove and replace. Insulated tweezers or extractors, these are good so that way you don't have to stick your fingers into tight places and possibly get them cut or possibly deal with an energized surface. It makes it a little bit easier to be able to pull stuff out. Operating system recovery media, I like flash drives, but there are plenty of people who still use optical discs. And there's tons of other non-essential tools that can be tailored depending on what your particular job is. If you work in a situation where you have if you work with home theater or if you work with car electronics, obviously the toolkit's probably going to need to change. What will not change, however, is the need to organize what you have. So a toolbox is a great idea. What I often recommend is that you go to a place like Harbor Freight, pick up a toolbox that you feel is of satisfactory size, and usually the fewer organizational components inside, the better. Now that seems counterintuitive, but what it comes down to for me is the ability to customize. So what I often do is also go over and buy a 3-pack of the $9.99 floor mats, the spongy EVA foam craft mats that you can use to line a floor in order to make it a little bit more safe for your feet. What I do is I take an X-Acto knife or a box cutter and trim those to be able to cut dividers or whatever else I need. So these are just some examples of different tools that technicians may need while repairing, upgrading, or maintaining a computer. You can see gloves, a pair of pliers, power supply tester, a post card for dealing with power on self-test checking, multimeter, loopback plug, continuity tester, flashlight, alcohol wipes. You can also pick up a fairly cheap package of glasses wipes, the lens cleaning wipes, and those can be used to clean sensitive glass products. So if you ever have to clean the laser head on a CD/DVD drive, or if you ever have to clean off a monitor and you don't want to keep a whole bottle of or a whole package of wipes to be able to clean a monitor or other electronic devices, relatively small cleans can be done with those wipes. I get some from Zeiss. Those tend to be fairly useful. Power supply tester, which I just called out a second ago. This is a specialized tool that you use to plug into the P1 connection on the device, and it will measure and identify the voltages of each connector rail. So let's say here you can see that it's got a 5.1 lead, 12.1 lead, and a 3.3 lead. So that means that a tenth of a volt on the 5 and 12 lines are out of the ordinary. The plus 12 you can see over there on the bottom left is at 11.6, still within the traditionally the 5% or so range that we tend to assign. So if you're ever curious about how your power supply is behaving versus the benchmarks, you can test it that way. Some motherboards will actually include that testing for you. There are usually also connectors for auxiliaries, so things like PCI Express, CPU, Molex, and SATA. So if you ever need to make sure that it's not the supply that's bad, but the connector, you can follow that particular rabbit hole. Now, this is a multimeter. This measures several characteristics of electricity. So if you think back to our Appendix A stuff, you can see that we can measure voltage, both AC and DC, as well as resistance. And then there's another item called continuity. Continuity is basically to identify whenever a circuit is complete or capable of accurate conduction. So if you have a line that has a break in it, that would be an indicator of a discontinuity. Loopback plugs are used to test device ports to make sure they're working. Certain loopbacks can also be used to test how fast a port operates. So let's say that you're testing out network interface cards for an upgrade and you want to make sure that they run at least 100 megabits per second. You can go ahead and test that. And if you get back one that says that it only runs at 10 megabits, then obviously that fails the test. If you find some that say that they run gigabit, go ahead and swap them out for the hundreds and bring the gigabits to me. Only joking, of course. But testing throughput is an important way to see whether or not it is a physical or a software-based issue that is causing a problem for a port. So that's step one. Let's take a look at step two, opening up the case and actually examining the system. So let's look at some terminology, stuff that you've probably heard before, but again, we got to make sure that baseline is there, right? The case for a computer is sometimes called the chassis, or box, or rig. You hear a couple of things. And they house all the primary components of the system. Now, cases can be decorative, but in my mind, I like to think that form follows function. So you want to make sure that you're getting the correct form factor, meaning the correct size for the components with which you are working. The power supply, motherboard, processor, RAM, expansion cards, everything else has to be able to fit in this bad boy. So you want to make sure that when you're planning your project later on this semester, you have the ability to say, okay, I want a video card that's a particular size, I know the length, is it going to fit in my case? So some different types of cases that we might see would be things like tower cases. The graphic on the right is a slimline tower case. Towers tend to sit upright and hold multiple drives. In this case, this is actually kind of a modified desktop case that's on its side. So you can see that the buttons, ports, and everything else would make perfect sense if it was sitting on its what is now its right side instead of on its left side, which is what's mounted into the stand. You can see the panel where a DVD or CD slot would go, as well as the smaller rectangle below it where a floppy drive might go, or a multi-card reader. So tower sits upright, usually holds multiple drives. Desktop lays flat, sometimes acts as a monitor stand to conserve space on the desk. Mobile cases are custom and are used for things like laptops and tablets, as well as phones. And then, of course, all-in-ones. All-in-one systems combine a monitor with the entire computing device into a single casing, again, to try and provide a measure of convenience. Unfortunately for technicians, that tends to provide a lot of complications, and for customers tends to provide a moderate functionality for a premium price tag. So when we open up the case, we need to do a little preparation first. Of course, we want to make sure that data is backed up. We want to make sure that the system is powered down, unplugged, and drained. And then we want to make sure we have something to catch our screws and other small parts. There's a couple of things you can do. Like I said, you can get a tackle box at Harbor Freight, craft sorter. You know, things that maybe somebody who makes necklaces or jewelry have these little bead sorters they can pick up. You can usually go over to a place like Tuesday Morning and find quite a few there. Multi-day pill minders that you can pick up at the grocery store, at the pharmacy. Very environmentally friendly and reusable options. Normally, of course, they don't think of plastics as being very environmentally friendly, but they do take a lot of time to degrade, and they're fairly resilient in the face of damage, impact, and just day-to-day friction. I have a toolbox that belonged to my grandfather, and he, I think, purchased it in 1965, according to the little thing stamped on the bottom of it. So, you know, depending, you know, they can last quite a while. Now, the toolbox itself is metal, but it does have kind of like a truck bed style plastic lining, and that does look fairly new. Once we go ahead and get into the case, let's go ahead and take a look at how we're going to get the panels off. Some cases require that you remove the faceplate, or what's called the fascia, F-A-S-C-I-A, first. You can remove one side panel or both. It depends on the case and what you're doing. If you're pulling out a optical drive and it's mounted on both sides, obviously taking both side panels off would be a good idea. Locating the screws or clips that hold the side panel in place would be your next task, and then we go ahead and remove them. Some of them have what's called knurling on the sides, which is where you have those grooves or ridges like you'd see on the side of a coin. This is to improve grip for, you know, your hands, so you're able to turn it by hand to unscrew it. Sometimes you'll have to involve a screwdriver, sometimes you'll have to involve an Allen wrench. I've seen some that have little hex heads on them. So here we see some graphics kind of showing us a little bit of the logic about how we decide which side panel to remove. You can see in the left-hand side the I/O shield for this particular motherboard. Obviously, if we're working on components attached to said motherboard, we would need to remove the opposite panel. If we need to remove something that requires access on both sides, then of course we would remove the second. Now here we see somebody in the white handling gloves removing the screws that hold the panel in place. Something interesting to point out about this particular case, very similar to my own, is that while it has a plexi panel on the side, there are mounts to attach fans, multiple fans in case. We do want to be careful about this because if the cable to attach these fans to a power supply is under tension, we don't want to damage that connection, so we want to be very cautious about how we remove that panel. Here we can see that they're just sliding the panel back, lifting it away, and then grounding themselves by clipping their ESD bracelet to a live metal surface. So we'll go ahead and clip in and take a look at the main components: power supply, motherboard, and drives. Obviously if there are expansion cards, we want to take note of those too. For most of my stuff, I tend to consider the RAM an expansion card as well because it has the same perpendicular connection to the motherboard. So go ahead and follow the cables from each component to its connector on the motherboard to identify what each cable's purpose is. And it's important that we understand orientation and order of connections. Now, order of connections may not necessarily matter for some things, but it is important to understand order may matter in, let's say that we've got a drive configured a certain way. Everything seems to work, but when we plug it back in, we have moved something from one port to another. Maybe something's disabled and it no longer works. So that order may or may not have been important. Just one more thing that we want to make sure we document to be able to restore the system to its original functionality. So this is kind of what we would be looking at if we were to open up a case. So we see that we've got some hard drives mounted, we've got optical drive mounted up there, we've got RAM, we can see a fan, the processor is going to be underneath that. That's part of what's called the cooler assembly. Motherboard, SATA data cables, power supply, and power cords. Now, the main internal components, we see the motherboard, processor, and cooler. And this is one we have to be kind of cautious about because the processor and cooler are linked together pretty tightly to the point where there's a small bit of lubricant in between the two to make sure there's no air pockets so that conductivity going from the CPU out to the heatsink and thus the fan are optimal. The main board, system board, or MOBO, the motherboard, contains a socket to hold the processor as well as connectors for all of your other peripherals and components. The processor handles the data and instructions for the entire system. Most people refer to it as the brain. Now, passing that much voltage consistently through impure silicon and germanium tends to generate a lot of heat. So as such, there needs to be a heat sink or method for drawing heat away from that device on top. The heatsink and fan package is traditionally called the cooler assembly or processor cooler. There's a lot of duplicate terms I'm sure you'll run into, but in general, we try and keep them at least somewhat analogous. Now, all hardware is either directly on board or connected to the motherboard to facilitate communication with the CPU, meaning that is the George Washington Bridge of passing everything back and forth between components and the central processing unit. Operating system has to talk to the CPU, graphics card has to talk to the CPU, RAM, chipset, everything. Now, your adapter cards or expansion cards are circuit boards that provide more ports than were originally provided when your motherboard was manufactured. A lot of computer customization today relies on the idea that a motherboard provides more slots than actual onboard function. That said, there are still a lot of ports that are automatically included by your motherboard and should be considered during the design process. Memory modules, traditionally random access memory, also called RAM, are temporary storage for data and instructions as they are being processed by the CPU. The type of slots that we traditionally use today are what are called DIMMs, dual inline memory modules. Dual inline basically means that instead of having a pin that we connect to only being functional on one side independently, the pins on the left and right side of a RAM stick operate independently, meaning that the connector can be 144 pins long but have 288 connections, one on each side of the stick, the printed circuit board. So here we have an example of an expansion card, graphics card. And the easiest way to identify it is to look at the ports at the end. We can see there's a DVI connection, there's a Super Video or S-Video connection there, and a 15-pin analog video port, traditionally called VGA. Now, this may not be necessarily obvious to you at the beginning, but identifying what ports go to what item can give you some cross-reference to be able to figure out where something particularly goes. Of course, there's also usually a model number or an ID sticker stamped somewhere on the card itself. Here we can see the RAM slots color-coded directly on the motherboard. We can see that there is only one slot currently active when installed, dim, and then the other three. The different coloring traditionally leans on what we call RAM channeling, which we'll review in a later chapter. Now, hard drives and other drives. Hard drives also may be called hard disk drives. That's traditionally magnetics. And then we have solid-state drives and solid-state magnetic hybrids. These are permanent, though I tend to call them long-term because they do eventually degrade, types of storage used to hold data and programs. All drives in a system are installed in a stack of bays at the front of the case. The power supply, also known as the PSU or power supply unit, converts house current that it receives from 115 volts into the usable plus or minus 12, 5 VSB, and 3.3. Now remember, of course, that I only want you to concern yourself with the 5, 12, and 3.3. Most come with a dual voltage selector switch, allowing you to move from 115 to 220. This is beneficial because we want to make sure that whenever we're working in an international environment that we can still support our customers. If we have customers in Germany and we have customers in Canada and customers in Australia, we want to make sure that our device will work with them wherever. Here we have some examples of different hard drives that might be available. On the left, we've got the larger magnetic. This is a thinner 3.5-inch drive on the left and a 2.5-inch solid-state drive in the middle. On the right-hand side, we have a full 3-inch DVD drive. Definitely very thick compared to a hard drive, but it uses the same style bay. Here we can see a power supply with the attached power cables, not connected to anything, but just kind of spooling outwards. You can also tell if you look closely at the texture of these that they have a flexible nylon mesh jacket over the power supply cables so that they can be flexed and curved a little bit and still be able to maintain a good deal of strength. I mentioned the term earlier, and it's important that we revisit it. Form factors are standards that describe the size, shape, screw hole, positions, and other major features of a computer case, as well as other components that are traditionally considered to be core components. So things like the power supply, motherboard. So something that is considered to be a full-size ATX motherboard would need to be a full-size ATX case. Power supplies would also probably want to match so that way everything anchors safely. Now there are a number of cases, one I own included, that have multiple mount points and multiple screw holes to be able to support different form factors simultaneously. This still means that you have to go through the process of figuring out how everything's going to line up before you start mounting it all in, so that way you don't have a component that is impinging upon another. Matching form factors are absolutely necessary so that everything plays nicely and is compatible. So these are some of the different form factors that you can expect to see. Mini ITX, Flex, Micro, Standard Full Size, Baby ATs, Standard ATs, and you can see how the different holes all line up. So if you had a full size ATX case and it also supported AT and Baby AT, you could see that it would be very simple to simply line up about, 20, 25 holes and just be able to allow it to mount however you need to. ATX is the most common, however. It stands for Advanced Technology Extended. Most common form factor used today, developed by Intel back in the mid-90s, and is considered to be an open, non-proprietary industry specification. ATX power supplies have a number of different connectors because over time they've had to evolve to carry new technologies. Things have needed some auxiliaries here and there. Your CPU needs an additional 12 volts. We make sure that we've got a 4-pin or an 8-pin to carry it. The primary connector, which we call the P1, has changed over time as well, going from a 20-pin to a 24-pin to a 20+ 4-pin, which allows support for both. The additional connector, the 4 pins, allowed us to support what's called the new, still now it's kind of old standard, but they keep updating it, PCI Express slots. There are also auxiliary PCI Express connectors for graphics cards, 6-pin, 8-pin, and in the class of the new RTX 3000 series, the 12-pin connectors. And that's usually just going to modify existing 6 or 8 pins to merge them together. Micro ATX is a major variation that aim to reduce the total cost of a system by saying, hey, let's cut down on the physical size. We'll cut down the number of slots, we'll cut down how much power the board needs, and now we can fit everything in a smaller case, generate less heat. It uses a 24-pin P1 and is not as likely to have as many extra connectors on the ATX supply, which is why we often use modular supplies, allowing us to pick and choose which connectors are available. Here we can see a micro ATX motherboard made by BioStar that's built for an AMD processor, so it has a pin grid array. You can see those little perforations there in the socket. You can also see that it's got smaller component spaces, so the components are more squashed together. The back of the I/O shield also has fewer options. The connections for the hard drives are tucked up in the top right corner, and there are fewer expansion slots, as was originally noted. There's also only 2 RAM slots as opposed to the 4 that most of us are used to seeing. Now, let's go ahead and get to the removal process. Let's take out our expansion cards first. So, when possible, draw a diagram of everything you've got going on. The book recommends that you use a felt tip marker to mark components in order to indicate a cable connection, board placement, orientation, etc. I prefer using photographs. Drawing on things with markers is not a good way to endear yourself to your clients if you're working in a professional capacity. To remove expansion cards, make sure you remove any tethering wires or cables. Remove the screw holding the card to the case. Grasp the card with both hands and firmly lift it straight up while, if you need to, rocking it from end to end. Now, you don't want to rock it towards and away from you. If you're facing it, you want to make sure it's along the connector, not across it, because the solder points on the base of that connector are not going to be strong enough to retain connectivity if you keep a strong tension on them. Be careful not to put your fingers on the edge connectors or touch a chip. Wearing gloves is a good idea here. Just make sure that they are not anything made of wool, maybe something that's got some insulated latex. I've definitely seen some cheap gloves that are just, standard cloth gloves, and the palms and fingers are dipped in latex to coat them. Rubberized substances do not conduct electricity well. And it's always best to, once you have removed a card, put it in an anti-static bag. So being able to do that with a RAM stick or an audio card or anything like that is always a good plan. Having some spare anti-static bags is never a poor investment. So here we can see the card needing to come up. Now, in this case, there is a retention mechanism. There's a little tab, almost looks like a joystick that gets held down. You may also have like a little slide that locks the card in place. So if you've got some resistance coming, go ahead and check the connector and make sure there's not a step that you may have missed at that point. Now we're going to remove the motherboard. We've taken out the expansion cards, including the RAM, and we should have cleared all the major power connectors out of the way. So let's go ahead and make sure our SATA data lines are also cleared. Our front panel connectors, this is one that you want to make a very precise diagram of before disconnecting. I don't mean necessarily you have to get it down to like centimeters and millimeters and stuff, but just like, okay, I've got a connector for my power switch. I want to make sure that it's turned the correct way. I don't want to have it 90 degrees off or 180 degrees off, etc. I want to make sure I know what order things are in. I want to make sure I know what's the positive and negative leads. So a very close inspection of that will make sure that your system is restored to the same settings it had when it got started. Be sure to remove any other cables or wires that may be connected. The screws that hold the motherboard to the case, which are mounted into what are called spacers or standoffs, will then be removable. This is where having a pair of tweezers or an extractor would be very helpful. There's lots of components right next to these screws that may possibly tear up your fingers if you're not careful. The motherboard should then be free to remove from the case. Just gently lift it straight upwards, making sure to not catch it on any other components. Set it gently onto an anti-static foam, into an anti-static bag, preferably keeping the original materials that it came with when it was installed. In order to allow the motherboard to run, it requires a set of instructions. And there is a built-in set of instructions that we call firmware, somewhere between half hardware and half software. Now, if we talk about the older firmware, it's traditionally referred to as BIOS. The newer stuff is UEFI. But because UEFI includes the BIOS materials for legacy purposes, it contains both. BIOS contains 3 subsystems identified as System, Startup, and Setup. System BIOS allows you to essentially deal with the powering up of the device from the time you push the power button. Then it transfers over to Startup BIOS, which starts looking for the boot sector of the hard disk or other storage material that contains your operating system. Setup BIOS is slightly outside of that. It allows you to make changes to the BIOS system itself. UEFI is a little bit more robust and certainly more secure. It uses platform keys and trusted software and hardware authentication to make sure that no rogue operating system hijacks you. Post is going to be involved in both of these and is a series of tests performed by the startup firmware. Usually, if you have it set up for the defaults, it will give you a little beep or similar confirmation that everything works well. If you hear an error or several beeps in a sequence, then that may tell you that something is not quite right. If you have a boot problem that you suspect is related to the hardware of the motherboard, there's an expansion slot card you can put in called a post card. They also sometimes are built in directly to the motherboard itself, maybe a set of LED lights, or maybe connected via serial connection or USB. The card monitors the boot process and relays any errors that are discovered. So here we have an example of a very old universal original PCI post card, postcode master developed by Microsystems Developments. And you can see that there's a set of LED lights as well as a little speaker, that's what that brown bit is, and the LED number output that will give you an idea of what is going on, what may or may not be giving you problems. Next step is to remove the power supply. Now the reason that we take out the power supply before the drives is just to make some space, but the reason we take out the motherboard before the power supply is to prevent us dropping it on the motherboard and possibly damaging it. So let's look for the screws that attach the power supply to the case, but not the ones that hold the casing together. So we want to make sure that they're screws that when we start to loosen them should not cause the power supply to start to rattle, but just should kind of release it from the case. And again, if you look at the position of those, we will be able to see them a little bit more clearly, ones that hold it to the case versus the ones that are holding the casing together. Sometimes power supplies are also have these underside slots that are recessed that are on a track, and they can slide back and forth in order to better anchor themselves into the case. Just make sure that you're not trying to force it in the wrong direction. So here we see the mounting screws being taken out. You can see that the screws are actually overlapping the metal of the case, not simply flush on the face of the power supply itself. They usually also use a different style of screw. They usually try and use a screw for the casing that is flat and flush with the power supply itself, whereas the others that you're supposed to remove tend to be a bit more prominent physically. Then we take out the drives. Drives receive power from a cable from the power supply, so they have a SATA connector usually, and communicate data instructions through a SATA data cable. Now, in order to remove these drives, we want to make sure that those cables are removed safely and in the correct order. What I usually do is feed them out the front of the bay to which the drive is connected if it faces outside of the computer, or just make sure it stays in the same general area if it's an internal drive. Look for screws, look for catches, look for clips. There's a ton of different ways that it might be removed. The best thing I can recommend is to check your motherboard documentation. So here we can see a SATA cable connecting to a motherboard in order to provide access to SATA data transmission. Now the thing I want you to pay attention to is if you look at the gray ones on the front row facing us, you see that there's a small lip on the left hand side kind of facing in, so it makes kind of a what would look like an upside down L or J pattern depending on your perspective. I would say L, just if we were to do the 90-degree rotation, and that helps you to prevent putting the cable in the wrong way. It is not a 180-degree reversible cable. It has to be faced one way only. And then here we can see the front panel being removed as we did when we were talking about how to take off the side panel before. This may be something that's necessary for the optical drive. The drive may only slide in or out once that fascia is removed. Now here we have a floppy drive that has a clip that must be depressed in order to push the drive forward out of the removable bay. And here we see a drive bay that has drives that are mounted in place with screws and possibly have their own fan assembly. Those are usually for older style file servers. You can see that the hard drive is much thicker than the one we saw in a previous graphic. Now once we're done with all this, how do we flip it around? Well, reassembly. So we take the same steps we just did, and if we've done good documentation, we should be able to do it in reverse. So again, refer to any diagrams that you've made. Follow the reverse order of what we just did for assembly. I will say that the drives In order to, again, maintain a little bit of extra space, you may want to do the power supply first. That's really the only variance from the reverse engineering, if you will. Also, with installing the drives, if we leave any bay-based drives with the cables hanging out of the front, it may make it a little bit easier to run the drives back in and not have to fight for space in a very tight corner to try and get those cables reconnected. Place your motherboard back inside the case, make sure everything lines up. Before you put the motherboard down, it may be a good time to make sure all of your spacers or standoffs are tightly screwed into place. What you don't want to have happen is when you screw the mounting screw in, if you have to undo it for any reason, you don't want it to automatically start turning the threads to undo the standoff as well, because you can then sometimes get your motherboard stuck. Then you have to break out the pliers and make sure you're holding the standoff from underneath as you unscrew it. Connect the power cords from the power supply to the motherboard. P1 is always used, but the auxiliary for the CPU may also be used. Again, refer to your documentation. Was it connected when you took it apart? It should probably be connected when you put it back in, except for in the case of upgrading or replacing a component. So here we can see that auxiliary 4-pin very, very close to the CPU. It'll usually say like CPU auxiliary or something similar stamped on the motherboard. Then let's go ahead and connect the wire leads from the front of the case to the front panel headers. And then to orient larger connectors, look for small marks on the connector that mark pin 1. You'll traditionally see like a little triangle or something similar. If the labels on the motherboard are unclear, consult the documentation for help. A magnifying glass never went amiss. Connect other wires to ports on the front panel of the case, such as your audio or USB ports. Those will usually be labeled, and again, hopefully you've done some photo documentation to make sure everything goes back where it came from. So here we can see the 7 connectors from the front panel that are most commonly present. We can see the USB and audio connectors, and if you look, you can see that the shiny bits are in slightly different configurations for the audio and USB. That's because they each have a dead or a dummy pin that is not present that prevents them from being connected to the wrong ports. There we see our reset switch, our power LED, which for some reason is always split up into 2. I've never been able to figure out why it's not one connector, but that's just me. The HD LED and the power switch. Now you may have some auxiliary connectors for certain cases, especially if they have like colored lights or things like that. Here we can see a little bit more in depth for certain motherboards what the documentation would actually look like. You can see the plus or minuses for everything. Normally, if we look at the plus or minus of a particular connector, we look for whether or not it's got a colored or a light or dark colored stripe that alternates it out. Most of the time, whatever has the color or the stripe on it will be your positive lead. So here we can see the ports that are connected to the front panel connectors. The USB ones that we see there are normally connected to that black big rectangular USB connection we see inside on the front panel connectors. Some of the others may, however, be a big blue cable that would connect to a USB 3.0 port. Go ahead and install your video card, other expansion cards. If there's anything new you're installing, make sure that you do it one at a time. You don't want to do what's called big bang installation, which is where you're hooking everything up at once and then booting it up and expecting the computer to recognize all this new equipment. Now, if you're doing this for a brand new install, everything's just scratch built, I would say go ahead and use the onboard video first as well as the onboard audio. Get your primary operating system stuff taken care of, get your upgrades done. Then you can go ahead and install your video card, get those updates done, switch over from your onboard video, do the same thing for your audio. And then if you have a network card or if you have a different type of peripheral interface, again, do them one at a time. Because remember, if something goes wrong and you've just done 4 major changes, you're not going to know which one is the problem. But if you do them one at a time and something goes wrong, then you have a much clearer trail. If you see something that's not quite right, make sure that you check for loose connections, things like that. Plug in your monitor, keyboard, and mouse, your primary I/O. So if you can use onboard ports, I do still keep a PS2 style keyboard and mouse with the big purple and green plugs, just in case for whatever reason the USB interface isn't working correctly. In a classroom environment such as this, you're going to have me check your work to make sure everything's working normally and that all of your connections are safely placed. Remember to always start least invasive and escalate only when necessary. And again, you'll learn that with experience, what is or is not something that would need quote-unquote escalation. So now let's take a peek-see at laptops. Now this is largely the same stuff, but there are some little side tips that we're going to have to address. Laptops are designed for portability and can be just as powerful as a desktop, but because things have to be miniaturized, because things have to use less power, because they have to operate on the move and be a little bit more resilient to shock, there's going to be a higher cost. So there's tons of different laptops out there, all have different types of performance. Maybe it's a touch screen, maybe it's a rotatable or removable screen, a netbook, which is a little bit less powerful but still very portable. Netbooks and ebooks were very popular in the, I'd say, the mid 2000s up to the, I'd say, about 2010 or 2012. And then all-in-ones, of course, are also included. They're built together into a monitor and case. They're not really a laptop at that point, but there are laptops that do try and combine all-in-one features. So here we see several common ports on a Sony Vaio laptop. You know, things like network interfaces, audio ports, USB. There may be some additionals as well. Generally, you're going to have an external audio port just for headphones at the very least. If not, then you'll have USB. And then, of course, video ports, HDMI being very common. DisplayPort is going to be something you'll see more on Apple. And then most laptops also include some kind of expandable storage, more often than not flash memory, at least the older ones. Now they tend to just lean towards flash drives, but you will still see some that have SD card slots for digital cameras. This is a cable lock system, what's called a Kensington lock, and you can see in the right-hand graphic that there's a little T-shaped stem that comes out of the lock. And what happens is you slide it into the slot and then rotate the lock so that it goes 90 degrees. And you usually do this by pressing the button down on the right-hand side of that yellow bit. And what happens there is that you then spin the shackle, the little keyboard, the little key wheels, in order to scramble the code. When the key code is unscrambled and the yellow button is pressed down to engage the code given, it will then spin the lock back 90 degrees and open it up. The reason this is beneficial is because it's connected to a weaved metal chain in a jacket, so that is going to be very difficult to try and break away from wherever it's anchored to. If you look in the left-hand graphic, you'll see that it's kind of looped like a bike chain through itself in order to wrap around a desk. So if you look at your desk in the classroom, you'll see there are these little open slots, and that is to be able to provide a space to feed that cable through to anchor it. So if somebody tries to do a snatch and grab running past you, they're going to have something that yanks that laptop right back out of their hands. Now, that may still damage the laptop, but the likelihood is that it will stay in your possession and you can try and get it fixed. So we can see here that USB is also incredibly useful. Universal serial bus, that's the idea. That it can provide connections that would otherwise not be present on your device, kind of like an expansion card would be on a desktop. Here we have a USB to RJ45, and then there are also USB to Wi-Fi, such as this. You can see the USB device here, what we would call a cradle point router, or cradle point antenna, excuse me. This is actually a cellular one that would have a SIM card of its own that would allow you to connect the same way that you would if you had a cell phone that was tethered to your device, also called sometimes an air card or a hotspot. 3G, 4G is most common, but I believe there are some new 5G ones out as well. So some special things we want to consider for a laptop. The F buttons, the function keys, if you will. Things like being able to modify the volume or media controls, so rewind, fast forward, play, pause, etc. The backlight of your keyboard if it has one. The backlighting of your screen. The orientation of your screen, whether or not your touchpad is turned on. Your external connections such as Bluetooth or Wi-Fi. GPS. Whether or not you have multiple displays, you can set those on or off. So if you hold the function key, you can make those changes. Interesting one also is being able to turn the num lock on or off. On a laptop, you'll often see that it has a couple of keys on the keyboard, like the IOP, KL, semicolon, greater than, less than, question mark area turned into 1 through 9, and then one of the alts being turned into 0, so that you can have a numpad on a smaller keyboard. Problem is, if you don't know that key is active, you might mistype a password or something similar. So just something to be looking out for. Some laptops have a connector called a docking port, connects to a docking station. Docking station essentially allows you to connect to a peripheral series of materials that are going to essentially turn your laptop into a desktop. Full-size monitor, full-size keyboard, plugged into the wall, other peripherals like a printer. You can also get what's called a port replicator, which is a universal docking station. These are non-proprietary that will allow you to connect to different types of laptops to allow you to connect to different peripheral devices very quickly. So this may be a high-speed USB that connects to a monitor as well as several other peripherals all at once. To use these items, you go ahead and plug everything in, connect the laptop to the station or replicator, and there's no software needed. It's able to just kind of take over on its own, plug and play. So this would be an example of the two. We see a docking station for a Lenovo ThinkPad on the left, and we see a port replicator on the right from, I believe it's Wavelink. I think that's who makes it. And you see that there's an Ethernet connector, DVI, HDMI, 4 USB 2.0, 1 3.0, and then there's the USB connector that goes to PC. That is a B-shell styled USB 3.0, so that is a very high traffic connection. Now, laptops cost more than desktops, so their parts must cost more also. Things to also consider is that the original equipment manufacturer, or OEM, may have a warranty present, and there may be things that are provided by the manufacturer, such as a service manual, diagnostic software, or even a custom operating system, something that's been modified to include usually what we refer to as bloatware. There's also a need to order replacement parts directly from an authorized source, if not the manufacturer directly, because nobody else makes them. So if there's warranty concerns, we need to make sure whether or not the laptop is still under warranty before we service it. When you're contacting technical support to verify this stuff, you'll need to make sure you know what model of laptop you're dealing with, what the serial number is. For Dell, they have what's called an express service tag. Who purchased it, their phone number and address. Hopefully they registered the warranty when they bought it. It is definitely a good idea to do so. Service options tend to be threefold, either physical on-site service, shipping it to a service center, or for something that's kind of low intensity, you can get it done over the phone or through an online chat. Again, it's just at that point they're providing the service of looking things up for you and telling you what to do. That doesn't mean necessarily that the service is going to be to your benefit. It just may mean that you're exhausting your options before you have to ship it to someone else. Now, service manuals are invaluable. They save a ton of time. Service manuals are very different than a user manual. These are going to show kind of exploded views of a laptop, being able to do specific types of replacement for parts, different techniques to be able to troubleshoot things that are beyond the usual. Most manufacturers only release these to authorized service centers, but I believe there's legislation now, very much as it would be for a car, called the right to repair, to allow this information to be releasable to the general public. Locating a service manual can be as simple as going to the manufacturer's website or going through different third-party sites like iFixit or various forums depending on what type of laptop you're working with. The user manual is just going to provide basic maintenance tasks, so don't be fooled. If the service manual link is there and you pull it and it's only like 6 or 7 pages, that's not a service manual. That's just a user manual or a quick start. Service manuals tend to be 20, 40, 100 pages, sometimes more. When we're talking about diagnostic tools provided by manufacturers, that tends to be things like PC Doctor. That's an example of one. A lot of diagnostic software is included in that kind of capacity. But you can also download free third-party tools like things like Malwarebytes, which is not necessarily for whether or not your hard drive is working correctly, but it will look out for abnormal performance, memory hogs, things like that. So here we have an example of VioCare as included by Sony, and it could be able to diagnose various hardware problems. You may not actually have to have that previously installed. You may be able to go to the website of the manufacturer and download it directly. Now, when we're working inside of a laptop, upgrading memory, exchanging a hard drive, replacing something that's broken, we have to use often smaller tools because the screws and other connectors are smaller than they would be on a desktop. There's more patience required, sometimes slightly more finesse and technique. And of course, we should always make sure we're wearing an ESD strap because things being close together means there's a lot more potential for mishaps and accidental discharges. So here we see some of the tools we would use for disassembling a laptop. A little dental pick to lift a plastic screw cover away, an extractor to be able to pick up small pieces, a putty knife or spreader to be able to open up the bezel, separating it from the rest of the body. The bezel is just the little plastic part that goes around things like the keyboard. And then of course your ESD strap. Work methodically, keep yourself organized. There's tons of different ways to keep small parts put away. I obviously won't bore you by trying to read these, but in general, find a method that works for you. Make sure it's something that's not going to make more static, and that it's something that's reusable if at all possible, just to make your life easier. So here they have a notepad that allows you to organize pretty comfortably. And then they have one that's kind of weird on the right-hand side. This is from the 9th edition, but I wanted to carry it over because it leads to a much better idea, which is to tape screws beside the removal step in the documentation. What I have seen somebody do before instead is to use little Ziploc baggies that they then tape to the page, which are clear, to give you a place to stick the various parts as you're moving through things. And you can see they're using a 3-ring binder here so you can flip between pages. You want to be careful about that though, because you don't want the baggie to tear open or to make things kind of lumpy, especially if there's anything that has like a magnet in it. If we're working inside of a laptop, of course, find the manual, consider the warranty, make sure we don't void it, take your time, make sure you're grounded correctly, understand how ZIF connectors work. ZIF stands for zero insertion force. They apply force evenly across a connector to prevent undue stress on small parts. The ribbon cable that you use to connect your keyboard is a ZIF connector. You lift the little latch and slide the ribbon out. There's no actual pins that go in contact unless you count the little metal stripes on the tape, as it were. A ZIF connector on a processor slot is going to use a metal bar to leverage the CPU into or out of the connector to make sure you're not going to break the pins. That's an AMD thing. We're going to get into processors a bit more deeply in a later lecture, and we'll talk all about the difference between a PGA and LGA connection. Be aware that you might have plastic screws that can only be used once. So of course you want to make sure that you have replacements if possible, or in certain cases, if the company that you work for says it's okay, or you, if it's your company, you can just replace it with metal screws, something that's a bit more sturdy. Make sure that you disassemble your components in order according to the service manual, which may not necessarily fall into the disassembly order that is proposed by this lecture. Obviously there are certain things that may be different if it's a proprietary structure. So here we can see the ZIF connector in action to lift out a cable connector. You can see that the cable itself on the right is either orange, white, or on the left-hand side it's going to be blue. But just lifting that little latch opens up the pressure on the cable. If you guys ask me in class, I'll be more than happy to diagram how that works. But essentially, the turning thing, the hinge there, is thicker on the front side than it is on the bottom, so that it applies pressure only when in that locked position. And of course, when we're putting it back together, follow the reverse order process. But again, remember, because the disassembly process may be slightly out of order from what you're used to, follow your documentation. Make sure that you tighten screws so that they don't just fall back out, but don't over tighten them until you're sure that everything's in the correct place. And even then, over tightening is a bad idea, because if you have thin screws, therein lies a possibility you might break something. Before you install the power source and then energize everything, just do a quick check to make sure there's no loose parts. The easiest way to do that is just to pick it up and give it a little shake. If you hear something rattling, there's probably something you missed. And again, just be methodical. Make sure your connections are done with patience and with a strong level of attention to detail. So here are some typical components and their extraction order. Unplug, remove the battery. There's not really a discharge process for this because the power source is usually much lower wattage, but you can press and hold the power button for a second if you like. Take out the hard drive, the RAM. Sometimes these will have their own little panels that you can use to remove them. Wireless card, optical drive. Go ahead and crack the case and start separating those panels. Take off the keyboard bezel, take off the system board. And then once you've got the system board out, you'll take off the CPU, heatsink, and fan. Again, your mileage may vary depending on what device you're disassembling. Be sure not to touch an LCD panel with sharp objects. The polarizer tends to be very thin and very easy to scratch, and once it scratches, it starts peeling off, and it makes it very difficult to use that screen. OEM battery packs are recommended, but some of the third-party ones are actually pretty nice. I use one for my wife's laptop. It provides a little bit of lift by putting a little extra height on the bottom to allow some better airflow. Be sure to not pick up a laptop or hold it by its lid where the display is. The hinges are not built to support that kind of weight and will snap. Make sure you don't pack it in a suitcase. Laptop carrying cases have very soft foam that they use to insulate those devices, so if it gets banged into, the foam will collapse a little bit more easily, and it won't translate that shock into the device and possibly cause it to break. Make sure that while the hard drive is being accessed, magnetic hard drive, mind you, that you don't move it around a whole lot, bounce it up and down, because those are very sensitive to impacts. Make sure you don't put it too close to an appliance that generates a strong magnetic field. Could possibly cause data corruption. Use strong passwords so that way if your device is left open on a desk, somebody doesn't try and get into it, or somebody steals it, it's not worth anything to them because they can't get past the password screen. Keep your notebook at room temperature. High humidity, low humidity, high cold or heat can be very negative to the performance of those devices. Keep them away from contaminants. Don't power it up and down necessarily. That'll weaken the battery. Don't run it while in a case, on a pillow, or covered by a blanket. Feels very Sam I Am, doesn't it? Very Green Eggs and Ham. Make sure that you're not blocking the ventilation, essentially is what it's saying there. Protect the notebook against ESD. Don't put it in high static areas. Remove optical discs or USB drives before traveling. USB drives can obviously be snapped off very easily, and discs can essentially get dislodged while they're inside the drive and possibly get stuck. So that's not something you want either. Take precautions if your notebook gets wet. Find a way to dry it out. And then keep current backups of important data outside of the laptop so that they can be restored at a later time if need be. Cleaning, very important. Soft dry cloth for the LCD. Compressed air is good. Be careful though, because it does blow everything around. So if you're in an environment where you don't want a bunch of dust to be sitting, maybe use something like an anti-static vacuum. Costs a little bit more, but it's more reusable and definitely keeps everything contained. Contact cleaner can be useful if you have a problem with your battery. Maybe there's some tarnish on those connections. All-in-one computers. I'm not terribly fond of these, but I do understand their purpose. We use them in the classroom to make sure you guys have a comfortable workstation, right? So for an all-in-one computer, there's a mix of components for a desktop and a laptop. If you need replacements for certain components, you'll probably have to go back to the manufacturer because they're proprietary in some way. Certain cables are cut to custom length, certain formatted, different peripherals may not work correctly. There may be a replacement for a webcam that's mounted into the motherboard and the monitor that has to be a certain size. Service manual is going to be your guide there. But again, bear in mind, all-in-ones are going to be, like anything else, if they're built for a custom purpose, probably going to cost a custom price. So here we see a diagram of the components inside of an all-in-one computer. Definitely kind of a hodgepodge there. You can see a full-size hard drive, but laptop RAM. You can see a laptop-sized cooling assembly. You can see that the optical drive is mounted on one side. There's a control board on the other. The power supply is at the top of the device, which I've never been a fan of. I think it makes it top heavy. All the inputs are at the bottom, so there's a lot of stuff kind of spinning things around, a lot of custom design there, which means that, again, that money is going to be spent on trying to recoup that design process rather than providing the best possible customization. That is the Chapter 1 notes. So there's your summary if you need to look over it. Certainly a good idea. Remember, of course, that these slides are available for your perusal in our Blackboard lecture slides folder. So just make sure that you're grabbing the 10th edition slides. There may be some minor formatting differences, but as long as it's the 10th edition, it says 2020 in the file name, you should be good to go. All right, guys. Well, I certainly appreciate your time and attention. Thank you so much for watching. If you have any questions or concerns, of course, you can always email me or contact me through my Google Voice number. And other than that, I will see you in class. Have a wonderful rest of your day.